Lecture 11, Metric Compatibility and Christoffel Symbols of Second Kind. Okay? From previous lectures of the same part here, part 6, the covariant derivative of the covariant second order components, okay? T, mu nu. Mu nu here is a lower indices. This is given by this relation 1. And also this notation appear in the literature sometimes. This is covariant derivatives, capital D over here, okay? Then I just copy from the previous lectures, okay, and wrote here, this is equation 1. Now, you see, this characteristic of the metric, okay, the metric compatibility is, you can see clearly as follows. You see, parallel transport of this component of the metric by definition is the dot product between a mu and a nu. You see, that's why you get a mu nu. Now, you have to observe that the parallel transport of each of these vectors, okay, in this case, the covariant basis, a mu, a nu, this clearly, this will be 0. Why? Why? Because the parallelism of a mu, okay, in this case, and the parallelism of a nu is 0, okay, according to the previous video. You see, the covariant derivative of this vector and this vector, they are 0. Yeah, 0. That's why, you see, you have an angle between a mu and a nu. If you move in a curve, you see the dot product remains the same. Okay? That's why each individually vector here, the covariant here, is 0. Okay? Consequently, the covariant derivative of g mu is 0. This is a very, very, very important result to obtain the Christoffel symbols of second kind. Now, you see, from equation 1 and 2, you see this equation 2 and equation 1, you see the covariant of g mu nu, which is, this is just a copy from here. See, you just look at here, then you set is equal to 0, since this relation, it was obtained from relation 2. Okay? Now, in this case, attention now, alpha, mu nu are free indices. Okay? Free indices. This alpha here, okay, is in the denominator, in this case, is upper index in the denominator. So alpha here is covariant. Don't forget that. Alpha, mu, nu, they are free indices. Okay? You can see on the right hand side, you see alpha, mu, nu, alpha, mu, nu, alpha, mu, nu. Here, rho is dummy. Rho is dummy. Okay? So this equation here is the heart to obtain the Christoffel symbol of second kind. I just transport this to here. Okay? I just copy from here and I wrote over here. So this will be 0. You see? This will be 0. Now I repeat this equation here, okay, just doing a permutation. That's clear. I write two more equations from this one, just using the permutation. See, alpha mu nu, and so on. Alpha corresponds to 1, mu to 2, and ni to 3. After 3 comes 1. After 1 comes 2. After 2 comes 3. It's quite easy. If you follow this, you look alpha here, and you look alpha over there. You see the next one, alpha, you'll be substitute by the next one, is mu here. Mu, you look at here, okay? Then you'll be substitute, okay, this mu over here by the nu, okay? So you see, look at here, you see? After nu, attention now, after nu comes alpha. After nu comes alpha. This I can apply it in this term over here. Just easy, okay? It's a rotation, permutation is better. Now I look at here, then I'll make the next permutation. After mu comes nu. You see, after mu comes nu. After alpha, attention. After alpha comes nu. Will be the second equation here. Easy. Okay? Then you just look at here, copy, and check the permutation. From this, I got this. From this, I'll get this. I'll get this. Okay? Just make the permutation. Okay. These are equations 4, 5, and 6. Now, the conventional way to coming up to the Christoffel symbols, you just, attention now, you subtract from equation 4, these two equations over here, this will be 0. See? That's a common, conventional way to do it. Now it's quite easy. You see, you just copy from here this minus that. Okay? This 5 and 6. Okay, if you write here, you can cancel this term over here with this one, and this term over here with this one. So it was left this green one, this green one. Attention now. This here will be plus. This here will be plus because you are doing this difference here, okay? This minus sign, okay, reach this sign here will be plus. Reach this sign over here will be plus. And also these are equal terms. Just look at here. You see, because mu nu and nu mu, they are equal. Okay, since the Christoffel symbols, okay, you can say that it is symmetric under mu nu, nu mu. You see? Now you can cancel this one, and cancel that one. Okay? So again, I'm subtracting from 4, 5, and 6. When you subtract, this will be plus, this will be plus. You see me? There I just write this term over here. You see, this minus here, okay, minus here, plus 2 times, okay, this term here, which is a green one. Okay, I can mark it here for you to understand clearly. Okay, this is the green one. See, I just repeat. Now equal to 0. Now I multiply both sides by minus 1. Okay, and then if I multiply by minus 1, this term over here, okay, gamma rho mu nu, gamma, this case, you have mu nu here, You see, I just isolate this term. Okay, this term will be 1/2 of this black one. Attention now. It's important. You see, plus here and plus there. Okay, why? Why? It's clear. If I multiply by -1, okay, and bring this term to the right hand side, you'll be plus. Okay, this one you'll be minus. Attention now. Okay, that's it. Clear. This is easy algebra. Now, then I isolate this term is 1/2 of this black letters. That's there. Now, if I multiply both sides by, you see, I want to isolate just this term over here. Okay. So I multiply by G lambda alpha, and know that G rho alpha, G lambda alpha is just the chronic delta. Okay, delta rho lambda. Okay, delta rho lambda acts on rho, and this gives lambda. Okay, it's a property of the chronic delta. Now the right hand side is just multiplied by this red one here. Okay, that's it. So that's a Christoffel symbol of second kind. Okay, gamma mu nu lambda. Attention now, G lambda nu, 1/2 of this bracket here, this parenthesis. This parenthesis I just copy from there. Attention now. Now it's very, it's clear, but I will repeat. You see, mu, nu, and lambda, they are free indices. Free index. This one is upper.